Good morning, amazing students. So, this video is to highlight quadratic regression. So, this word should sound somewhat familiar because we did it for linear equations with linear regression. And what that is that gives us the equation for the line of best fit. So, if I had like a scatter plot of a quadratic, and hopefully we all realize a quadratic is a parabola. Let's say I had it kind of scattered where it didn't make a straight line parabola, but you can tell that it's making a parabola if I drew a line of best fit. Well, what quadratic regression is going to do is give us the actual equation for the line of best fit. So the line that best fits our data on the quadratic. So, how do I find that line of best fit? Well, I would make sure that I have my data points. Okay, and usually they'll give you a graph or they'll give you a table, and make sure your equation's in standard form. And just like we did for linear regression, we're going to put it all in Desmos. So, plus sign, add a table, put in the table, and we're going to put in our quadratic equation, except remember it has to read the table. So, based on our table, y1 squiggle ax1 squared plus bx1 plus c. So we're going to use our quadratic regression equation, and it will give us our a, our b, and our c value. And then that will give us, and we can plug those back in for our equation. So let's look at an example to make sure we understand. A projectile is launched in the air from the ground. The table shows the height of the projectile at different times. Based on the table, which function can be used to model this situation? Well, it's looking for the equation. Well, I'm going to put this table into Desmos. So plus sign, add a table. We have 5, 10, 15, 20, 25, 30, 35, 1,353, 2,460. And so we're just writing down whatever the table they gave us, I'm putting it into Desmos. From here, my table says x1 and y1. So I'm going to write down my quadratic equation. And I know this is a quadratic because, one, looking at the answer choices, they all have squares on the variable telling me this is a quadratic. Also, if a projectile is being launched in the air, that's going to go in a parabola, right? Go up and then go down. So this is also going to be forming a parabola. All right, so y1 squiggle. Let me show it on here. ax1 squared plus bx1 plus c. When I do that, it gives me an a value, a b value, and c value. I'm not sure if it's going to let me write and do this at the same time. So it gave me an a value, a negative 4.9. It gave me a b value, 294, and a c value of 0.57. So that would be equation B. So it's just that. Add the table into Desmos and write the quadratic regression equation. This is our A, this is our B, and this is our C. And that's in the equation. For y equals ax squared plus bx plus c. So this is our standard form quadratic. Let's look at another example. So here we have another object is launched into the air. The table shows the object's height above the ground at various times. Based on the table, which of the following is closest to the object's height above the ground? 9 seconds after being launched. Well, this one's a little different, okay? This time, it's not asking for my equation, it's asking for a specific thing. So the x-axis represents time, The y-axis represents height. It's asking above the ground at 9 seconds. That would be x. So it's asking when x equals 9, what is our y value, question mark. So let's go ahead and put this table into Desmos. So I'm going to go ahead and exit this table out and add a new table. So 1, 2, 3, 4, 5, 6, 78, 109, 131, 143, 145, 137. Doing the same thing. Y1, squiggle, don't judge me, I keep forgetting what the name of that squiggle is. AX1 squared plus BX1. And a reminder, the reason I'm having to put X1 and Y1 is because my table says X1 and Y1. And it needs to be able to read my table. Plus C. Here, I get an A value, negative 4.9. I'm going to just have to round this. A B value of 46.2 and a C value of 36.5. Now I have two options here. I could look on my graph and figure out, well, when x is 9, what is y? And so I could search on my graph when x is 9, what is y? Oops. I'll get there eventually. Alright, so I can get like maybe a rough estimate here. It's 54.821. So it would be at 54.821 meters. That's me using the graph. So if I rounded that, about 55. Or I can use my equation. So for the A value, we got negative 4.9. For the B value, we got 46.2. And for the C value, we got 36.5. And I could plug in 9 into x and see what that would give me. So going back to Desmos again. So let's see. Negative, and this is going to be a rough estimate because I'm rounding my numbers, right? And this is squared. And I'm using my keyboard as well. Just save my own time. So here we get is 55.1. So 55 would be my closest answer. Okay, so it's important you know what it's asking for. All right. Last example. A table of values for the quadratic function g is shown below. Which of the following statements about the graph of g are true? Well, I don't know. I need to go figure out what the graph of g looks like. So again, I'm going to plug this into my Desmos. So exit this, exit, exit. All right. So negative 1, 2, 5, 6, 9, 10, 12, 14. Negative 55, negative 16. 5, 8, 5, 0, negative 16, negative 40. All right. Again, y1, squiggle ax1 squared plus bx1 plus c. And that gives me the a value of negative 1, b value of 14, and c value of negative 40. Okay, so let's look at what this is saying. So I'm going to press the home key here so we can see our parabola. Okay, it says which of the following statements of the graph are true? The graph has a line of symmetry at x equals 7. Remember, our line of symmetry will basically split our parabola in half. It's a vertical line, VUX, x equals equation. So it's saying that the vertex, or our maximum here, because this is a down-facing parabola, the vertex will have an x value of 7. Well, let's check. Oh, look. Our x value here is 7 on the vertex, our maximum. And so that means our line would go through x equals 7 would be our axis symmetry. So that is a true statement. The graph has a y-intercept at 0, negative 40. I don't know. Let's go look. Okay, and this question, a question about the y-intercept, was actually one of the most missed questions on the quarter 3 exam when we have graphs to look at the y-intercept. So I'm looking at my y-intercept. There it is, negative 40 on the y. That is a true statement of 0, negative 40. The graph has an x-intercept at 4, 0. I don't know. Let's go look. Okay, so my encouragement is take your time looking. You have something that giving you the answers. It's your job to know what each thing means. So it has an x-intercept at 4, 0, and it has an x-intercept at 10, 0. So yes, one of the x-intercepts is at 4, 0. And the graph has a vertex at 6, 8. Well, we already looked at what the vertex was. The vertex is at 7, 9. Remember, the vertex is the maximum or the minimum, but in this case, it is a maximum. So the vertex is actually at 7, 9, not 6, 8. So the only true statements are 1, 2, and 3. And how did I do that? I graphed it on Desmos. Use your tools. Awesome. Have a great day.